Hi, good evening all. This is Vishal Singhal from CellStrat. Thank you for joining our webinar and sparing your time for the good topic today, which is Inception. It is being delivered by Mr. Gouthaman Asokan, who is senior engineer with Western Digital. He is also interning with CellStrat as a deep learning research intern. Uh, and now I'll be in a few minutes I'll be handing it over to him. But before that, we would like to understand what kind of audience we have, so that we will be able to give relevant example as well as tell you in uh, tell you in detail as to what's being talked about and give you relevant examples. So I'm distributing a poll here to understand our audience. Please respond to the same. So more people to go. Since we talk about data all the time in AI, it's data for us as to what kind of audience we get and how we can help them. Still more people to go. So I'm seeing there's a mix of people. So there are currently about 65% are saying they are learning deep learning. About 15% work in AI ML and rest 15% are working in deep learning already. Great. Thank you. Next is what age group you are on. If you see, I have put in 12 to 17 as well because I have had calls from school students who know deep learning now, 11th and 12th standard students. So always try to understand what kind of age group we are getting on our webinar. By the way, in our AI labs, we have started getting some student interest as well from school. So I say age is a myth, as well as salaries in this domain are a myth. There is no upper level of salaries, and there is no lower age group where people are learning this. So more people to go. Please respond. Please respond. Rest of you. Even if you are above 60 or between 12 to 15, no worries, because we have got both side of students in our courses, webinars, AI lab. So in our student profile as of now, we have 65-year plus students studying deep learning or interning with us, and that gentleman is from Italy. So others are not responding. So about 15% of you belong to 17 to 25, 50% between 25 to 45, and 33% between 45 plus to 60. Great, thank you. Good mix of people today. And which part of the world are you coming from? Wow. Okay. Interesting. So more people to go, please. Okay, so about 10% of you are from out of India. I recognize one gentleman. He's from Japan. About 70% of you from South India is expected, and 10% from North India as well. Great. And generally, we don't get very many people from North India. Great. Thanks a lot. So that was the polls part. So now I'll hand over the presentation to Mr. Gouthaman. Gouthaman, it's all yours. Please go ahead. Share your screen.
Sure. Good evening. My name is Gouthaman, and I'm presently working as a deep learning intern at CellStrat. and today I'm going to talk about inception. So, what is inception?
So, Gottman, just one last statement. So, we are recording this webinar. Recording would be available in 2-3 days' time over our CellStrat YouTube channel. I'll put that on the chat for question panels for all to see, as well as if you have any questions, please keep on putting them on question panel so that if it is slide critical, we will respond at that time. Otherwise, we will try to attend to all question and answers towards the end of the webinar. Thank you. So go ahead, Gautam.
So, first to understand about inception, we need to know about what computer vision is about. Computer vision helps us in recognizing the images and object detection. For that, the primary thing that we use is convolutional neural network. So this is a type of neural network where the patterns on the images are being recognized with minimal pre-processing. And the famous data set for the computer vision is ImageNet. So the ImageNet, it comprises of approximately 1 million images, and these have been trained again and again, and seen whether the accuracy is being achieved. So this started around and it has been happening every year ever since. And ImageNet is being seen as a bar to reach for your CNN architecture to be considered as good. So the ImageNet large-scale visual recognition challenge is one that happens every year in the computer vision community, and you can even see the data set in the Kaggle for this. And state-of-the-art algorithms that has been coming, and one of the most important in that is computer vision inception model. So here you see the accuracy of different architectures, and if you see in the bottom, inception is able to have a lot of accuracy compared to the other architectures that has been similarly designed over these years. Some of the most famous architectures are AlexNet, GoogleNet, which is the inception, the ResNet, VGG. So these models have been compared and seen that inception is proving to be a very accurate model compared to the other models. Guys, could you see the changing slide actually? So now I'm in scene and block. So this is the CNN block, the basic architecture of the computer vision. Here we have an input image, and in this we do a convolution, and after that you have pulling thing, and after that you have flattening step. So these are the major steps. The convolution helps in understanding what are the features that are present, and the pooling helps in averaging or maxing the features into a smaller dimension. And this is being fed to in a neural network, by flattening it out and understanding what this image is about. So this is the basic CNN architecture on which the other models like Inception, ResNet, VGG are being built. So we could be asking why the name Inception. So Inception came from this very meme. You guys could have seen the movie of Inception. DiCaprio would be telling we need to be going deeper and deeper in dreams. So that is the same motto with computer vision enthusiasts. They try to go deeper and deeper in the neural networks, and that is why the person Google who found out kept the name of Inception for this particular computer vision architecture. So next we need to be knowing why this model. So here slide, if you could see, there are different images of dogs. The dog is just as a very close up, and one is at a very distant, and one is at the normal exposure. So here, the challenge that we have in building a neural network is that we need to capture all the features of the dog. So if we keep a large kernel size, we will be able to capture the first image, great, but that wouldn't apply to the second and third image. So if we have a filter size low, it would capture the features of the third dog, but again it would fail for the first and second dog. So the features of the image should be captured, however angle the dog is there and whatever the distance it is there. So this is a major problem in the computer vision. The second thing is going deeper and deeper. So that is actually very computationally expensive. So once you stack layers after layers, the model becomes slower and slower, and you couldn't train it on a large data set. It takes a lot of computational resources, and the cost exponentially increases. So as a solution to this, the inception model was being introduced. So here if you see, four parallel networks that has been going there. The first is the one cross one convolution. The second is the 3x3 convolution. The third is the 5x5 convolution, and the fourth is the 3x3 maximum. The 5x5 captures the features in the overall image. The 1x1 captures the features in the small tiny details, and 3x3 the medium features. So as it is being parallelly computed, all the features are being captured at once. So this greatly helps in capturing all the features that is required from the image. And through this thing, the previous slide where we saw the different dogs at different angles, every feature of it would be captured well. So this is the naive version of the inception model that we would be seeing. So there is one single problem with capturing the images as such. What the problem is being seen here, which is that if we need to change this image of 28 cross 28 cross 192. So what is 28 cross 28? This is the image size, the length and breadth. The 192 is the feature maps. This feature maps, if we need to reduce to a size of 32, we need to do a convolution. So this convolution that we do is the 5x5 convolution, and this 5x convolution we do it as a 32 filters of 5x5 to get this final size. So when you can calculate how much computation is being required to do such filtering, you will be seeing in the bottom that the size of the input image is 28 cross 28. The size of the filter that we see here is 5x5. The number of channels in the input image is 192. The number of filters of that 5x5 is 32. So which would come to the operations of 120 million. So this is a large number of computation that we would be required to process a single image. So the inception made a tiny tweak to the previously shown model, which helped in reducing the computation cost. So I'll be showing that.
Gouthaman, there is a question
this is
here.
how, yeah.
How do we decide if we have to take 5 by 5 filter or 3 by 3 filter?
So 5 by 5 is an example here. Like it is uh, it's a hyperparameter at first, and the inception model it uses both 1 cross 1, 3 cross 3, 5 cross 5. Here I am just showing a 5 cross 5 because it helps us in understanding how much computation would be required from the input to output to the single computation. So usually in the inception, it is going on a parallel processing with 1 cross 1, 3 cross 3, and 5 cross 5.
Okay, thank you.
So here if we see, the initial architecture of the inception has been added with 1 cross 1 convolutions at every step. We have a 1 cross 1 as a separate way, and we have a 1 cross 1 3 cross 3 convolution as another step. 5 cross 1 cross 1 5 cross 5 is another thing, and a maximum folding with 1 cross 1 as another step. So if we do like this, the convolution would be greatly reduced. So this may sound counterintuitive because we had a lesser number of blocks in the previous architecture. Now we have added a 1 cross 1 convolution at every single step. So how would the computation be reduced? So that just show in the next slide. So here we see that this 28 plus 28 plus 192 is again being reduced to 28 plus 28 plus 1 cross 32. So we have a 1 cross 1 convolution and followed by the 5 cross 5 convolution. So what happens here if we see this 28 cross 28 190 and 1 cross 1 of size 16 is being computed. That is being done. So again after that we are introducing the 5 cross 5. So again this 28 cross 28 with 16 future maps and 5 cross 5 filter with 32 filter size is being done. So if we add these two computations, it just comes to 12 million computations that has been required. So previously we saw that the computation that was required is 120 million, while here it is just 12 million. So there has been a tenfold reduction in the number of operations, and this is how the inception was born by introducing this parallel filters and introducing the 1 cross 1 convolution at the each parallel processing. So the inception model initially was being presented as a GOOGLENET, while a team in Google was the people who founded the inception model. And as they presented the model, they found that the large number of stacked layers led to diminishing gradients. So when you have a diminishing gradient, the initial value and the final value, the updated value will have a very small change. So once you have this diminishing gradients, the middle layers would have no learning. So they would have the same initial value as the epochs just gets progressing with tens and hundreds of epochs. So what they did, they tweaked the loss a little bit. So we usually find the loss at here, the final point. But what happens here is that we also find two auxiliary losses, one here and the second one here. So, so we have three parallel losses, and we calculate this total loss as the real loss plus 0.3 of the auxiliary loss 1 and 0.3 of the auxiliary loss 2. So, if we calculate the loss as this and update the values according to this middle layers will have a good learning, and as such would have a better accuracy. So this is one of the key features that was being displayed in the GOOGLENET. So in this GOOGLENET, there was 9 such layers, inception modules that were stacked, which was 22 layers deep. So another thing is, so Inception was conceived in 2014, but as the years progressed, that there was various versions of the Inception that was made, which made the versions better. So that is Inception V2, Inception V3, V4, and also there is Inception-RESNET architecture that has been has come out. So this B2, B3, B4, what are the talent features here? What are the trees that they have made? I'll just show you. And the first change is, so, we have this one cross one, maximum coding cross one cross one, and one cross one and three cross three. So these like the previous version, it has been kept as such. But the 5 cross 5 convolution, instead of doing as such as 5 cross 5, what it did was change it into 2 3 cross 3. So this saw as reduction in the computation. So little intuition how it may help us. 5 cross 5 is like 5 to 5 is 25. So just they made it into 3 cross 3 and 3 cross 3. So it would be something like 3 cross 3 plus 3 cross 3, which is 9 plus 9, 18. So 25 they decreased it to 18. So that the computation becoming lower. So that's one of the salient features has been seen in the later versions of the Inception. So another the thing that they have done is, like if there is a n cross n filter, they just made it into n cross 1 plus 1 cross n. So instead of doing just n cross n, they split it into the three, should again give the same features as a n cross n, but reduced computation. So again, this in the intuition level you could consider as n cross n as n square, and n cross 1 plus 1 cross n is 2n. So always see that n will be lower than n square, which makes the computation very low. And another feature that they added to the Inception model is, instead of going in a series, they just made it in a parallel. Instead of going deeper, they made the model a little wider. So instead of going with 1 cross 3 and after that at a 3 cross 1, what they did is they made it in a parallel way, so that the 1 cross 3 and 3 cross 1 happens at the same step, and after that the next thing is being made. So again, if we see in this V3 V4 model, there has been trains to make it wider instead of deeper, which helps in making the computation cost very low. So this is the some of the features that we see in the V2, V3, and V4 models. So another important thing in Inception is the Inception-RESNET model. So RESNET was a computer architecture that was discovered in 2015, and people have been trying to make the RESNET and Inception as a combined hybrid model. So what happens in ResNet is, it jumps the circuit, and the input layer is fed directly to the output of the another layer. So this helps in capturing the features that has been not captured through this model. So that comes the name residual network. So here if we see, we can see that this whole thing is the Inception module that we have been seeing in the previous slides. So what we did was, we send the image to this, and parallelly the input image is being directly fed here, and the output of the inception image is also being fed. So what happens here is we combine the both inception network and the residual, the RESTnet network, and this in turn helps in capturing what are the features in a more hybrid way, which helps in making the architecture even more effective. So the next thing that we would be seeing is so inception architecture. It has a lot of layers, but in a naive way of knowing what is this inception architecture and how it works is here through a Python code. So we will have just an inception module where we have parallelly a 1x1 filter, 3x3 filter, and 5x5 filter, and 3x5 maximum cooling. So once we have this parallel computations, this is being concatenated, and that is the layer that is being made as the output layer through which we will be going to each subsequent steps. And this F1 are the filters, and these are hyperparameters, and there's nothing of a rule that this should be of this size. We could select whatever be the number of filters that we want in each 1x1, 3x3, and 5x3, and see which makes the image classification better. So I have been trying to do this image classification with the help of the DATASET, which is Fruit 360. And here, what I have been using is transfer learning. So transfer learning, how it works is these layers are already pre-trained. We'll be using that pre-trained layers to identify how it is effective in understanding the images. And it's not always that inception would be the greatest accuracy. And here, if you see ResNet and inception ResNet has been able to attain 94% accuracy, while inception has been able to attain 73% accuracy, and VGG 63% accuracy. So VGG is something like stacking of the layers, and inception ResNet we saw in the previous module. So these are the things that I saw during the classification of the fruits dataset. So that is the main things that I have been seeing with the help of Inception ResNet. You could also go to GitHub of mine, Gouthaman Asokan, to just see what is this transfer learning, how it could be used for this different architectures and obtain the images. And there is also a naive version of the different architectures like VGG, ResNet, and Inception, and how it is being built. And any other doubts, I will also be able to answer to my mail ID, agouthaman1010 Thank you.
So thank you, Gouthaman. So audience, if you have any questions, this is the time. Although we have finished early, so we have a lot of time here. If you have any questions, please you can ask them now, and Gouthaman is available to respond. Otherwise, you can send questions to him, and uh, he'll be happy to answer. As well as I'll put the CellStrat YouTube channel right away. You look at it in about 3-4 days time, and this webinar would be posted there. I posted the YouTube channel where we post all the videos. Previous webinars are also available there, and uh, we will be having our next webinar on careers in AI/ML tomorrow, where we talk about what we offer in CellStrat, as well as what kind of career opportunities can people look forward to if they go into this domain. I'm not seeing any questions here. Please respond, else we will close the webinar. Audience, I'm seeing everybody was attending it very attentively, but I'm not seeing any questions. Either it has been explained very well, or you knew everything, because I'm not getting any doubts or questions here. So Gouthaman, I think we can take it that way, that it was explained very well, that there are no questions.
Yeah, sure.
So thank you for attending. Since we are not getting any questions here, so Gouthaman, one question has come. Is there any link to the sample code?
Code and also the main architecture of Inception, BGG and ResNet that you could refer to.
So is it on your GitHub, or is there some other link?
Yeah, yeah, it is in the GitHub.
So GitHub link is given on a slide. You can note that, and it can be, all code can be seen there. Any other questions, please? So no other questions are coming. So we will close the webinar for now. So thank you, Gouthaman, for sparing your time to give this webinar. Hope to have more such sessions from you in future. And thank you, audience from across the world. Have a good night in India and good day to all in the rest of the world. Thank you.